You can stand on a carrier flight deck and believe you understand the ship. The jet blast, the chains, the hand signals, the choreography around the catapults all feel complete. It is already one of the most mechanically intense places in the U.S. military, but that impression is incomplete in exactly the way surface impressions usually are. The flight deck is not the carrier. It is the visible skin of a much larger organism. Beneath it is a dense industrial interior that exists so aircraft can launch on time, recover safely, be refueled, be rearmed, be repaired, and do it again tomorrow. A modern aircraft carrier is a floating factory before it is anything else. It manufactures sortie generation, combat persistence, and the daily habits of sustained presence at sea. The official Navy fact file for aircraft carriers helps because it starts from function rather than spectacle. Carriers are the centerpiece of the forces necessary for forward operations, and their embarked air wings can attack targets in the air, afloat, and ashore that threaten control of the sea. Those mission statements sound large and strategic, but every strategic sentence rests on physical spaces. Every launch begins with maintenance completed somewhere below the deck. Every sortie depends on a weapon moved safely through controlled spaces. Every recovery depends on arresting gear, engineering support, fuel handling, watch rotations, and teams that most observers never see. That is why this episode goes downward. If you want to understand why a carrier matters, you have to understand the spaces that keep the flight deck alive. The first thing that defines those spaces is compartmentation. Naval ships are not arranged like office buildings, hotels, or airports, even when they contain thousands of people. They are arranged to survive damage, to preserve watertight integrity, and to keep vital functions separated enough that one accident does not automatically spread into another. That is why the interior experience of a carrier can feel so disorienting to anyone seeing it for the first time. Passageways repeat. Ladder wells connect decks vertically rather than gently. Doors are heavy, labeled, and purposeful. Compartments can feel interchangeable until experience teaches the difference. You are not meant to wander freely in the way you would through a civilian complex. The ship is built so movement can be controlled, damage can be isolated, and critical systems can keep operating even when the environment becomes hostile. That logic shows up in details people instinctively read as inconvenience. The steep ladders are not there because no one thought about comfort. The narrow passageways are not just design leftovers. The heavy doors and hatches are not theatrical naval decoration. They exist because sea service punishes loose design. Water moves where it can, fire moves where it can, smoke moves where it can. Pressure, heat, fuel, cables, and machinery all demand boundaries. A carrier, therefore, organizes life through boundaries. Some are administrative, some are safety rules, and some are built into the steel itself. Once you grasp that, the ship stops feeling merely cramped and starts feeling intentional. The Navy teaches this mentality through damage control culture as much as through architecture. Damage control competitions, repair locker drills, firefighting exercises, and pipe patching evolutions are not side activities for board crews. They are part of the ship's survival language. Official Navy coverage of carrier and destroyer damage control events shows the same pattern again and again. Teams race to don gear, rig hoses, isolate damage, apply patches, and communicate clearly under stress. Those training events are public glimpses of a deeper truth. The carrier stays operational because thousands of people rehearse how to keep bad news from becoming catastrophe. The flight deck may symbolize power, but damage control is where the ship proves discipline. That same discipline extends into propulsion, though public discussion has to be careful there. Carrier propulsion attracts mythology because nuclear power does two things at once. It offers extraordinary endurance, and it hides its most sensitive details behind obvious security boundaries. The official aircraft carrier fact file gives the public version cleanly enough. The Nimitz class uses 2 nuclear reactors, 4 shafts and 4 rudders, and the Ford class continues the Navy's nuclear carrier model with new design efficiencies. Public Navy and NAV-SEAA materials also make clear that the Ford class was built with more electrical generation margin and new systems designed for future technologies. That is enough to establish the point without pretending to know what public sources do not say. The carrier's engineering plant is not dramatic because it is secret. It is dramatic because it allows the ship to keep operating, launching aircraft, and powering everything from radar to workshops for long periods without depending on conventional refueling in the way smaller ships do. Even at this public level, propulsion changes how the interior of the ship feels. Steam, heat, vibration, electrical distribution, fluid systems, ventilation, and maintenance routines are everywhere below decks. You do not have to see the reactor spaces themselves to see the consequences of the energy they produce. They appear in catapult operations, aircraft support systems, air conditioning, freshwater production, lighting, elevators, and the endless background hum that makes the ship feel less like a vessel than like an inhabited machine. On Ford-class public pages, the Navy highlights the increase in electrical generation because future ships are expected to carry more demanding sensors and systems. That is an engineering statement, but it is also a statement about interior life. More power means more things can happen below deck without choking the ship's ability to keep everything else going. The hangar bay is where that hidden industrial logic becomes obvious even to outsiders. Here the carrier stops pretending to be a runway and admits that it is a maintenance plant for aircraft. Airframes are moved, inspected, fueled, armed, and repaired in a space that has to remain usable despite salt air, moving equipment, tight schedules, and the simple fact that sea conditions never stop mattering. The hangar bay is not glamorous because glamour is not its purpose. Its purpose is throughput and readiness. The carrier can only turn flight operations into persistent military effect if the hangar and support spaces keep aircraft cycling back toward readiness. Aircraft elevators connect that lower industrial world to the famous upper deck. Public Navy writing on Ford-class weapons and stores elevators emphasizes something observers rarely think about. A carrier only works at tempo when it can move material vertically with confidence. Weapons, parts, pallets, and support items must travel through the ship in an orderly way or the whole sortie generation rhythm degrades. Ford-class stories about the new advanced weapons elevators and improved stores elevators are useful because they show the Navy thinking about flow rather than only platform size. The ship is not stronger simply because it is large. It is stronger because it can move the right material to the right place with fewer delays. That word flow matters just as much in ordnance handling as it does in aircraft maintenance. Public coverage of carrier loading evolutions tends to show bombs, missiles, or pallets in dramatic snapshots. The reality is slower, stricter, and much more procedural. Ordnance movement is about safety boundaries, trained teams, inspection, secure stowage, and sequence. Aircraft cannot be armed simply because weapons exist somewhere on the ship. The right items have to move at the right time, in the right condition, with the right approvals, through a ship that is already busy doing several other things. When that system works, observers see fast launches. When it does not, the deck slows down even if the ocean outside is calm. Below deck, the Combat Information Center represents a different kind of industry. It does not manufacture parts or move pallets. It manufactures a usable picture. Public Navy imagery of CICs on carriers and escorts always carries the same mood. Low light, screens, headsets, posture, repetition. That repetition is the real story. CIC is not dramatic because alarms are constantly sounding. It is dramatic because watch teams spend long hours turning an ocean full of partial data into something commanders can trust. Contacts are tracked, correlated, reclassified, cross-checked, and handed upward. Communication is filtered by relevance because total information is not the same thing as useful information. The public often imagines command at sea in highly cinematic terms, as if the key moment were one senior officer dramatically deciding what to do in front of a glowing map. The actual command environment is more disciplined and less theatrical. depends on watch teams, standardized reporting, layered permissions, and a careful distinction between what is known, what is assumed, and what is still uncertain. That distinction matters because naval operations are full of ambiguity. A wrong contact classification, a delayed report, or a maintenance issue misunderstood as a tactical issue can distort the whole picture. The people in CIC therefore live in a world where precision of language is part of survivability. From there, it becomes easier to understand why food, water, and supply are not side notes in a carrier story. Pacific Fleet profile on USS Nimitz made this visible with numbers that sound almost absurd until you imagine what it takes to support a crew of thousands day after day. The ship can serve 18,000 meals per day and distill more than 400,000 gallons of fresh water from the sea. Those numbers are not trivia. They are operational facts. A carrier is not merely a weapons platform carrying humans. It is a human settlement built inside a warship, and settlements require daily industrial services if they expect people to stay sharp. The galley and mess decks are where the scale of that settlement becomes tangible. Food is inventory, but it is also morale, rhythm, and recovery. A crew standing long watches, flying sorties, conducting maintenance, and handling damage control training does not stay effective on a symbolic concept of logistics. It stays effective because someone ordered the stores, received the pallets, chilled the food, baked the bread, cleaned the lines, prepared the trays, and kept doing it after the novelty of deployment vanished. The joke that breakfast may be the most important weapon on the ship survives because it contains something operationally true. If the crew is not fed well enough to keep working, the aircraft will not fly with the tempo the mission requires. Fresh water sits in the same category. Distillation capacity rarely makes it into thumbnails or popular descriptions, but it shapes everything from cooking to hygiene to engineering routines. A ship at sea cannot assume easy replenishment of basic services. It has to make many of those services itself. That is why the carrier feels like a floating factory rather than a transport platform. It creates living conditions out of the sea, even while it is also creating sortie cycles out of steel, fuel, maintenance, and command. This is also where the glamorous and unglamorous parts of the carrier finally merge. The same ship that launches strike fighters also runs laundries, refrigeration spaces, machine shops, dental spaces, medical services, server rooms, supply offices, berthing compartments, and repair lockers. The same deployment that produces dramatic night launch footage also produces clogged systems, broken fittings, worn pumps, damaged cables, inventory mistakes, and the 1,000 quiet failures that disciplined crews prevent from cascading. Official Navy stories about ruptured pipes, emergency repairs, weapons elevators, and engineering upgrades are worth reading for exactly that reason. They remind you that military power is always riding on maintenance. Machine shops make that point with almost brutal honesty. Carrier at sea cannot afford to wait for every part from shore. Sailors and maintainers therefore fabricate, patch, machine, and improvise within controlled procedures to keep larger systems moving. This is not improvisation in the movie sense. It is professional repair work performed under the constraints of a deployed ship. A small repair may protect a larger schedule. A quickly fabricated fitting or properly patched line may preserve a mission no one outside the hull will ever know was close to disruption. The public sees a ship that kept operating. The crew sees a chain of small technical wins that prevented a breakdown from becoming operationally visible. Firefighting and casualty response reveal the same truth from the harsher direction. The Navy's public emphasis on damage control drills, fire suppression upgrades, and rapid repair is a reminder that everything below deck is connected by consequence even when it is separated by bulkheads. A fire in one space is never just a fire in one space. Smoke travels, heat moves, power can be lost. A flooded compartment is never just a wet room. It can alter stability, destroy equipment, block access, and force a command decision on a timeline no one wanted. That is why the carrier's hidden spaces are built around checklists, accountability, and watchfulness rather than around comfort or elegance. Crew life is shaped by that design. Berthing is functional first. Passageways are work paths before they are social space. Light, noise, and temperature are controlled to support ship operations, not private preference. Public Ford-class material that mentions climate control improvements or quality of life upgrades matters because it reveals the baseline expectation. Life aboard a carrier is demanding enough that even incremental improvements to airflow, habitability, and internal movement are strategically meaningful. Crew that sleeps poorly, eats poorly, and works in degraded spaces will still function for a time. It will not function as sharply, as safely, or as durably as the mission requires. This is why the carrier should be thought of as a labor system as much as a platform. Thousands of people do specialized work, but what gives the ship power is not only specialization. It is coordination. The cook, the electrician, the aviation ordnanceman, the machinist, the radar operator, the boatswain's mate, the supply chief, the corpsman, and the watch officer do not share a daily routine, but they share a dependency chain. A missed maintenance action on one deck can surface as a sortie delay on another. A supply problem that looks administrative in the morning can become tactical by evening. The carrier's hidden city works because those chains are understood, rehearsed, and respected. That fact also changes how we should think about scale. People love to describe carriers as floating cities because the phrase feels intuitive. But a city usually tolerates loose movement and a certain amount of inefficiency. A carrier does not. It is more accurate to call it a floating factory because factories live or die on flow, sequencing, safety, and sustained output. The output here is not a consumer good. It is the continued ability to launch aircraft, protect the ship, feed the crew, maintain the plant, and remain ready for orders that may never become public. The ship is a city in population terms. It is a factory in operational terms. Seen that way, the glamorous flight deck becomes the least mysterious part of the carrier. What is mysterious to outsiders is not that jets launch into the night. It is that they can keep launching after days or weeks at sea because the industrial organism below deck has kept pace. The elevator crews, ordnance handlers, maintainers, cooks, damage control teams, supply sailors, engineers, and watchstanders are the ones who turn a large ship into persistent power. They do not merely support the mission. They are the mission's endurance. So when the phrase below decks is used as if it meant a hidden curiosity tour, it undersells the point. The hidden spaces of a carrier are not interesting because they are secret. They are interesting because they explain how naval power survives contact with daily reality. They show how the Navy turns steel volume into living systems, and how living systems keep a deployed warship from becoming just an expensive object at sea. At night, the flight deck changes character. The roles are the same, but the environment becomes less forgiving. The deck is still crowded, the aircraft are still loud, and the ship is still moving, but visual cues are reduced. Lights, wands, aircraft lighting, deck markings, and disciplined positioning become even more important. Navy reporting on nighttime flight operations describes the work as requiring precision approaches and heightened coordination between pilots and controllers when darkness and weather reduce easy visual cues. Night operations show how much the system depends on controlled visibility. The deck is not simply flooded with light like a stadium because operational requirements and pilot visibility matter. Instead, the scene becomes a pattern of points. Lights on aircraft, lights on gear, reflective strips, silhouettes, and hand signals made readable in darkness. The deck crew has to know where people are, where aircraft are, and where invisible hazard zones begin. Night operations also show why routine is not the same as easy. A crew that has repeated the same movement hundreds of times in daylight still has to respect the change in conditions. Depth perception changes. Fatigue may be more pronounced. Communication has to be clean. The cost of confusion increases because there are fewer casual visual checks. The same deck feels narrower after sunset. That does not mean the Navy stops operating. It means the human system has to become more deliberate. Crews operate in darkness because naval aviation has to be available when missions require it. The color system, the hand signals, the deck status calls, the control tower, the pilot procedures, and the ship's training all have to remain coherent when the easiest cues are gone. Night operations also connect to the human side of carrier aviation. Crews do not perform one dramatic launch for a camera and then go home. They work watches, they operate in weather, they repeat procedures while tired. They trust the qualification system, the chain of command, and the training pipeline because personal instinct is not enough in the dark. A carrier's flight deck is only the most visible layer of the aviation system. Below and beside it are hangar spaces, elevators, maintenance areas, shops, and passageways that keep aircraft moving through the ship's daily rhythm. Aircraft do not simply live on the flight deck. They are moved, stored, maintained, and repositioned through a vertical system that connects the deck to the hangar. An aircraft elevator is a simple idea with serious consequences. It moves aircraft and equipment between levels, but it also creates a moving platform, an opening, and a schedule constraint. If the elevator is being used, the deck plan changes. If aircraft are below, they still need maintenance, power, and access. If aircraft are above, they still need to be tied down, spotted, and protected from weather and deck movement. Blue shirt roles and aircraft handlers matter here because movement is not limited to taxiing under engine power. Aircraft may be towed, wings may be folded, chocks and chains may be set or removed, tractors and support equipment may have to pass through tight areas. An observer who only watches launches misses the labor that makes launch order possible. Maintenance footage also changes how we understand readiness. Carrier aviation is not a collection of pristine machines waiting for a perfect moment. It is a maintenance-heavy system. Aircraft fly, return, get inspected, get serviced, and may be prepared again. The ship carries the people and equipment to do much of that work at sea. The hangar is not backstage in the entertainment sense. It is part of the main machine. This is what makes aircraft movement a logistics problem. Where does each aircraft go after recovery? Which one needs fuel? Which one needs maintenance? Which one is blocking another? Which elevator can move what? And when? How do crews avoid turning limited space into a traffic jam? The answer is the same answer we keep finding: roles, procedures, and controlled movement. Every flight deck system is built around normal operations, but it is also built around the possibility that normal operations will fail. Aircraft can malfunction. Equipment can break. Weather can shift. A person can be injured. Fire can start. A fuel issue can become urgent. The carrier cannot assume that help is nearby, because at sea the ship is often its own first responder. That is why crash and salvage drills, general quarters, mass casualty drills, tactical combat casualty care training, pipe patching, and firefighting belong in the same story as flight operations. They may seem separate from launching jets, but they are part of the same safety culture. The deck launches aircraft because the ship believes it can respond when something goes wrong. Red jerseys, crash crews, medical personnel, damage control teams, and every sailor trained in basic shipboard response form the emergency side of the flight deck system. A carrier is not only an airport, it is a ship. Fire, flooding, smoke, damaged equipment, and casualties are ship problems before they are public relations problems. Crews train because confusion during an emergency is expensive in seconds. Damage control is also a reminder that the ship cannot outsource survival. On land, a fire department may arrive from outside the facility. At sea, the first response is already on board. That changes the mindset. Sailors who are not assigned to the flight deck may still be part of the ship's emergency resilience. Flight operations depend on that wider shipboard culture. The same discipline that keeps aircraft moving also keeps the ship ready for casualty response. A sailor who learns to move through smoke, patch a pipe, respond to a casualty, or fight a fire is part of the reason the carrier can keep operating in hazardous environments. Flight deck can only move quickly if someone has authority over the whole picture. Individual crews know their jobs, but the ship also needs coordination above the deck level. Primary flight control, commonly called fly, and the air boss are central to that story. The air boss is responsible for the safe and efficient control of aircraft operations around the carrier's flight deck and nearby airspace. The mini-boss and the fly team support that control function. From the deck, a sailor may see one aircraft, one tractor path, one catapult area, or one piece of gear. From pre-fly, the picture is broader. Launches, recoveries, deck status, aircraft position, communications, and timing all have to be coordinated. The flight deck is not managed only from the deck itself. It is managed through layers of command and observation. This matters because carrier operations involve conflicting needs. A squadron wants aircraft ready. Maintenance teams need time. The ship may need to turn into the wind. Recovery windows may be approaching. Weather can change. Fuel states matter. The deck may need to be respotted. A delay in one place can affect another place minutes later. The command layer is what keeps those conflicts from becoming uncontrolled motion. This is one of the biggest differences between a carrier and a land airport. A civilian airport separates many functions over large distances: runways, taxiways, ramps, gates, maintenance areas, fire stations, and control towers. A carrier compresses those functions onto and inside a ship. The tower is closer. The runway is shorter. The parking area is the deck. The maintenance space is below. The ocean is moving. The result is a control problem that has to be solved every day. Fuel is one of the quiet systems behind every launch. A carrier aircraft may look ready because it is parked on the deck with a pilot nearby, but without aviation fuel, it is only a machine waiting for energy. Purple shirt fuel crews work in a space where fuel, hot engines, electrical equipment, moving aircraft, and people all exist close together. The work demands attention because aviation fuel is not just another supply item. It is one of the forces that makes the flight deck powerful and hazardous. No layer is perfect by itself. A colored jersey does not stop a jet. A catapult does not direct an aircraft. An arresting wire does not clear the landing area. A fire drill does not replace maintenance. A command decision does not move a chock. The system works because the layers overlap. People watch equipment. Equipment supports people. Procedures shape timing. Training prepares crews for the moment when timing breaks. This is why the flight deck remains one of the clearest examples of military engineering as a human system. The machines are powerful, but the machines are not enough. A carrier becomes an airfield because sailors turn steel space into controlled space. They mark roles with color. They move aircraft with hand signals. They maintain gear that absorbs and releases enormous energy. They train for darkness, weather, emergencies, and fatigue. They do it while the ship moves through the ocean. When the next jet moves toward the catapult, watch the whole deck. Watch the sailor who points. Watch the sailor who waits. Watch the person checking the gear. Watch the crew clearing the path. Watch the blast deflector rise. Watch the aircraft stop, then move, then disappear into the sky. The launch lasts only seconds. The system behind it took generations to build, and every safe launch depends on that system working one more time. Think about the forces crossing the deck at the same time. Aircraft bring thrust, heat, fuel, mass, and speed. The ship brings motion, wind, steel edges, elevators, and confined space. Crew brings training, signals, tools, and judgment. Carrier aviation works only when those forces are arranged in the right order. If thrust comes before clearance, risk rises. If movement comes before communication, risk rises. If speed comes before inspection, risk rises. The entire culture of the deck is designed to put order before motion. The ship also has to preserve options. A clear route for one aircraft may become an emergency route for another. A launch area may have to pause because recovery is coming. A maintenance problem may change the next deck arrangement. A weather change may force a different tempo. This is why experienced deck crews think in sequences rather than single actions. They are not only asking whether one aircraft can move, they are asking what that movement does to the next 5 minutes. The more you understand the deck, the less the word chaos fits. Chaos means nobody knows what will happen next. The carrier deck is the opposite. Many things happen quickly, but they happen inside boundaries. Aircraft do not wander. Crews do not choose random paths. Signals are not personal gestures. The deck is busy because the mission is demanding. It is controlled because the cost of uncontrolled movement is too high. That control is also why public carrier footage can be watched again and again. The first viewing shows aircraft. The second viewing shows people. The third viewing shows timing. After that, the deck begins to reveal the system. Who waits, who signals, who checks, who moves equipment, who stands near the gear, who stays clear, and how the aircraft passes from one part of the system to another. A final point is worth holding on to. The aircraft carrier is often described through size, cost, and firepower, but the flight deck shows a more practical truth. Naval power is a management problem. It is the problem of moving people, aircraft, fuel, weapons, tools, information, and emergency response through a small space without losing control. The ship's size is impressive, but the precision is what makes the size useful. That precision does not make the work safe in the ordinary sense. It makes the work survivable enough to repeat. Every safe launch is temporary proof that the system worked. Every safe recovery is another proof. Every reset, every inspection, every drill, and every restrained decision adds to the same result. The carrier does not defeat risk, it disciplines risk. This is the lesson behind the flight deck. The Navy can put aircraft at sea because it built a human and mechanical system around the most dangerous moments. Launch is not only acceleration. Recovery is not only stopping. Movement is not only towing. Fueling is not only filling. Maintenance is not only repair. Emergency training is not only practice. Each piece part of a larger promise. The ship will keep control of its own deck. That is why the flight deck remains one of the most intense workplaces in the world. It is loud, crowded, exposed, and unforgiving. But it is also ordered, trained, watched, and rehearsed. The people on that deck are not surviving by luck. They are working inside a system designed to make luck less important. The yellow shirt aircraft director is a useful place to begin because that role makes authority visible. A pilot may have rank, experience, and control of the aircraft, but on the deck, the pilot still depends on the director's signals. The director sees the aircraft in relation to other aircraft, tractors, deck edges, people, and equipment. The pilot sees instruments and the view from the cockpit. Safe movement comes from joining those views into one action. The green shirt world gives the deck its mechanical backbone. Launch and recovery equipment can appear permanent because it is built into the ship. But it still needs people. Catapult tracks, arresting gear, support equipment, and maintenance tools all require inspection and care. The machines make carrier aviation possible, but they do not excuse the crew from responsibility. They increase the need for technical discipline. The purple shirt fuel crew represents another kind of trust. Fuel has to arrive at the aircraft in the right amount, at the right time, under the right controls. If the aircraft is not fueled, it cannot perform. If the fueling area is poorly controlled, the deck inherits a hazard. Aviation fuel is therefore both a resource and a risk, and the crew treats it as both. The red shirt jobs remind us that the flight deck carries consequences. Ordnance, crash response, salvage, and firefighting duties sit close to the most dangerous energy on the ship. Their presence is a warning against thinking of flight operations as routine entertainment. The routine exists because teams are prepared for the abnormal. The blue shirt handlers and support crews often do work that disappears under the larger spectacle. Chocks, chains, tractors, tow bars, and elevator operations are not minor details. They are how aircraft become stable, movable, and correctly positioned. A carrier deck fails if aircraft cannot be secured as reliably as they are launched. The brown shirt plane captain brings the story back to individual aircraft. In a sea of machines, each aircraft still needs ownership and attention. Someone has to know whether that aircraft is ready, what has been checked, and what still needs attention. The plane captain role gives the aircraft a human point of responsibility inside a large system. White shirt roles show that safety is not an afterthought placed outside the operation. Safety, quality assurance, medical readiness, and landing signal functions are part of the operating environment. They do not exist to slow the deck for no reason. They exist because speed without oversight is only another word for risk. The shooter or catapult officer stands at the meeting point of human decision and mechanical force. A launch can look like one dramatic gesture, but that gesture comes after aircraft positioning, equipment readiness, pilot readiness, deck clearance, and communication. The shooter is not creating the launch alone. The shooter is releasing a sequence that many people prepared. Arresting gear crews live with the opposite problem. Instead of releasing stored energy into the aircraft, they prepare a system to absorb energy from it. A landing aircraft arrives fast, heavy, and committed. The deck has only a short distance to turn that arrival into a stop. Every inspection and maintenance action around the gear is connected to that moment. The night crew faces a deck that is familiar and unfamiliar at the same time. The routes are known, the roles are known, and the aircraft are known, but darkness changes the way the body reads distance and motion. Lights become language. Position becomes more important. A small misunderstanding can travel farther because there are fewer visual cues to catch it early. Damage control teams carry the ship's larger promise. If something breaks, burns, floods, or injures, the first answer is already aboard. A carrier is not simply a platform that sends aircraft away. It is a ship that must protect itself while doing so. The flight deck depends on that shipboard resilience, even when the emergency is not on the deck itself. The air boss and the command layer make the crowded deck part of an organized air operation. Local signals matter, but local signals need a larger plan. Launch timing, recovery timing, deck status, aircraft readiness, weather, and ship movement all come together above the level of one aircraft. Without command coordination, the deck would be a collection of skilled people solving separate problems. With coordination, they solve one shared problem. The launch sequence also shows how the Navy uses redundancy without wasting motion. More than one person is watching, more than one system is involved, more than one signal confirms readiness. Redundancy can look slow to outsiders, but it is what allows the final seconds to be fast. When the jet leaves the deck, it is moving quickly because the checks before it were deliberate. The recovery sequence uses the same principle from the opposite direction. The aircraft approaches, the landing area is controlled, the wire is ready, and the crew is prepared to clear the deck afterward. If the aircraft traps, the system resets. If it does not, the aircraft continues flying, and the system responds to that outcome as well. The operation is built around possibilities, not assumptions. Carrier aviation is also a story of compression. A land airfield can spread its functions across acres. Carrier compresses runway, ramp, fuel point, maintenance area, emergency response, and command environment into a ship. Compression creates efficiency, but it also creates risk. The flight deck system is the answer to that compression. The most honest way to describe the deck is manage danger. It is not safe in the casual sense. It is made safer through role clarity, technical systems, training, and command authority. That distinction matters. A dangerous job can still be professional. A hazardous environment can still be controlled. The Navy's achievement is not that nothing can go wrong. The achievement is that so much is arranged to prevent one mistake from becoming many mistakes. Every aircraft movement is also a communication event. Sometimes the communication is a hand signal. Sometimes it is a radio call. Sometimes it is a posture, a delay, a cleared path, or a raised piece of equipment. The deck speaks constantly, even when nobody nearby can hear ordinary speech. Learning to read that language is part of becoming useful on the flight deck. The carrier's aviation system reaches into the entire ship. Food, sleep, maintenance shops, engineering spaces, medical teams, supply departments, and command watchstanders all support the deck indirectly. A jet launch may happen in seconds, but those seconds rest on the ship's ability to sustain people and equipment for weeks or months at sea. That is why a long look at the flight deck is worth the time. It turns a familiar image into a readable system. The aircraft remains impressive, but it stops being the only subject. The real subject becomes coordination. The act of making many people and machines behave as one controlled operation while the ocean moves beneath them. The first hidden system is spacing. On a carrier deck, distance is not measured only in feet. It is measured in reaction time. A person standing 10 feet from the wrong part of an aircraft may be too close. A tractor moving slowly through the wrong path may still be dangerous. A parked aircraft may be secure in one deck arrangement and a problem in the next. The crew has to understand space as something active, not empty. A clear patch of deck is not simply unused steel. It may be a launch path, an emergency route, a safety boundary, or a space being protected for the next aircraft movement. The same pattern shows up in the Mediterranean. DVI's posted material showing USS Bulkley performing replenishment at sea with USNS Kanawha. Different theater, different combatant, different support ship, same underlying truth. Naval presence is sustained through repetition. The public might imagine deployments as a chain of tactical decisions and watchstanding moments. But the support chain is running alongside the tactical chain the entire time. A deployed ship does not merely operate. It remains operable because someone keeps extending its endurance, and then the pattern reaches the carrier force. DVDIS shows USS Nimitz conducting replenishment at sea with USNS Patuxent. It also shows Nimitz conducting vertical replenishment. In another example, daily operations aboard USS George H.W. Bush include vertical replenishment with USNS Arctic. Pause there for a moment, because this is where the hidden fleet stops being a side note and becomes impossible to ignore. The carrier is supposed to be the symbol of visible American sea power. Huge flight deck, air wing, escorts, command presence. Yet even in that public image, logistics keeps re-entering the frame. The giant ship still needs a support rhythm. The giant ship still has to be fed by a system outside itself. That is revealing in a deeper sense. When people talk about capital ships, they often talk as if size itself creates autonomy. Bigger deck, bigger reactor, bigger magazine, bigger myth. But size does not erase dependence. In some ways, it magnifies it. A larger combat platform can do more, but it also creates a larger sustainment burden around the things it does. If public Navy footage keeps showing replenishment folded into carrier activity, the lesson is simple. No matter how central a ship may be to public strategy language, it still lives inside a logistical ecosystem. Vertical replenishment is especially interesting because it dramatizes how sustainment can become part of the visible tempo of operations. On screen, a helicopter lift can feel less dramatic than a launch or recovery cycle, but strategically it is part of the same story. Cargo crossing that gap through the air says that resupply is not an administrative afterthought. It is embedded into how the force continues functioning at sea. The transfer itself becomes a kind of quiet proof that endurance is being renewed in real time. Once you see that, a strange inversion happens. The glamorous shot starts depending on the practical shot. The famous ship begins to look less like the whole story and more like the public face of a deeper machine. The logistics ship, the rigging crew, the cargo net, the helicopter crew, the line handlers, the crane team, the yard welders, the transport specialists, the fuel system trainers, they are not separate from Seapower. They are Seapower in its sustaining form. Military Sealift Command's own public material reinforces that idea directly. The 2026 MSC Command video highlights a global logistics mission and the organization's various roles. That kind of institutional video can easily be dismissed as generic command messaging. It should not be. Institutional language tells you how the Navy wants its support arm understood. Global logistics mission. Various personnel. Roles across the organization. That is not the vocabulary of side work. It is the vocabulary of a system that understands movement, sustainment, and enablement as mission itself. This is where the phrase hidden fleet really earns its weight. It does not only mean the support ships are less famous. It means the observer usually sees the results of support without seeing the support as a strategic subject in its own right. The support fleet is hidden because successful logistics tries to feel invisible. If the destroyer got what it needed, if the carrier remained operational, if the cargo arrived, if the part got installed, if the deployment stayed on schedule, then the public receives continuity and rarely asks how continuity was built. Continuity is the central product here. Not glamour, not drama, continuity. The ability to keep a force in motion across time without allowing ordinary friction to break it down. Fuel is friction, distance is friction, wear is friction, maintenance is friction, paperwork is friction, weather is friction. Transfer delays are friction, human fatigue is friction. Every Navy that intends to stay at sea for long periods lives in a permanent argument with friction. The hidden fleet exists so that the argument ends in extension instead of collapse. One of the strongest examples of this comes from the USNS Robert E. Peary material. D-Des describes Robert E. Peary returning home after a 154-day deployment, operated by Military Sealift Command Atlantic, supporting 4th Fleet combat readiness. That description carries more strategic weight than it first appears. 2. The phrase combat readiness often gets attached to aircraft, ships, and weapons systems, but here readiness is being supported by a dry cargo ship returning from a 5-month operational run. That is a reminder that readiness is not only the condition of the shooter, it is also the condition of the sustainment chain around the shooter. Think about what is implied there. A long deployment for a support ship means long-duration support for many other activities that may never headline themselves as logistics. It means one less dramatic platform is carrying a very dramatic share of the burden for ships and missions elsewhere. The ship can come home without a parade audience understanding that it has spent months making more visible operations possible. That is the hidden fleet in one image. Quiet return. Large consequence. The forklift symphony clip may be the perfect symbol of this whole episode. 4 forklift operators move a 60-foot-long crate as it is readied for shipping. There is something almost comic about how ordinary that sounds next to the public iconography of warships. And yet it may be one of the most honest scenes in the whole package, because large, awkward, essential objects do in fact need to be moved with discipline before more glamorous phases of military life can occur. Transport requests have to be answered. Routes have to be managed. Loads have to be controlled. Weight has to be treated as real, not theoretical. One reason observers lose sight of this is that successful logistics remove surprise. The crate arrives. The part is there. The fuel transfer worked. The support ship met the combatant. The drill validated. The deployment happened. Because the outcome feels smooth, the public forgets smoothness had to be manufactured. But the hidden fleet is, in many ways, the manufacturing of smoothness. That is why I want to spend time on the emotional logic of support work, not just the physical logic. Support culture is about responsibility without applause. A destroyer crew knows what it means to remain watchful in public. A carrier aviator knows what it means to perform under visible expectation. A shipyard rigger, crane operator, welder, or expeditionary fuel specialist often works under a different kind of pressure. Their work becomes most visible when it fails. Success looks quiet. Failure becomes obvious. That is a very specific professional burden. The hidden fleet, therefore, depends on a moral quality that can be hard to dramatize but easy to respect: consistency. The repeated willingness to do exacting work so that somebody else can operate with confidence later. The patience to take the careful path instead of the flashy path. The habit of thinking not only about today's task, but about the downstream consequences of doing that task badly. In a sense, support work is strategic humility made physical. Now let us return to the ships at sea, because the longer we stay ashore, the more clearly we can understand what the at-sea footage is really showing. When a destroyer takes fuel or cargo from a support ship, the public is not only seeing a resupply moment, it is seeing the entire hidden apparatus upstream of that moment. Somebody loaded the support ship, somebody managed the inventories, somebody maintained the transfer gear, somebody trained the crews, somebody planned the rendezvous, somebody handled the communications, Somebody kept the logistics network coherent enough that two moving ships could meet with purpose instead of hope. That is why replenishment at sea is such a powerful image once you stop treating it as routine. It is one of the rare moments when the hidden fleet becomes visible in direct contact with the visible fleet. The support ship literally comes alongside the combatant. The abstraction disappears. Dependence is no longer theoretical. It is line, distance, timing, seamanship, and transfer. There is a beautiful honesty to that. For a little while, the combat ship cannot pretend it is self-contained, and there is something else. Replenishment scenes are trust scenes, not trust in the sentimental sense, trust in the operational sense. Crews trust procedures. Ships trust station keeping. Commands trust planning. Each participant trusts that the other people in the chain have done their part well enough for the transfer to happen safely and usefully. The hidden fleet is not merely a set of assets. It is a trust network with steel and fuel attached to it. Public observers are often taught to think of naval strength as concentration of force, more missiles, bigger deck, better sensors, faster response. Those matter, but DV-IDs keep showing another form of strength that receives less attention. Reliability under repetition. If a force can repeat sustainment across theaters, across ship classes, across mission types, across shore and afloat contexts, that reliability becomes a form of strength all by itself. It means the force is not simply capable of dramatic moments. It is capable of lasting moments. Lasting moments are strategically more expensive than dramatic moments, which is another reason support deserves attention. It costs something to keep capability alive over time. It costs training. It costs maintenance culture. It costs specialized personnel. It costs the ability to accept that some of the most important work in the system will never look glamorous. The hidden fleet is where a Navy proves whether it values duration as much as appearance. The 2026 DV-IDs material makes a quiet argument that duration is exactly what is being rehearsed and displayed. Mustin is not replenished once in some ceremonial fashion. It appears in multiple sustainment relationships. Nimitz is not simply pictured as a carrier, it is pictured inside replenishment workflows. NAVLSG is not just described as an administrative organization. It is shown in fuel system and crane training built around readiness and mobilization. The third MEB drill is not abstract readiness language. It is recall and logistical process validation. The field sterilization event is not peripheral medicine. It is expeditionary support capability. The shipyard clips are not generic industrial mood footage. They are concrete examples of repair, modernization, and transport work that keep the fleet fit for follow-on use. Taken together, these clips form something larger than a pile of B-roll. They form a public map of sustainment culture. A public map, importantly, because none of this is secret in the broad sense. The Navy is openly showing observers what kinds of support activity matter. We simply have to take those signals seriously. There is a tendency in military storytelling to treat support as what happens before the real story begins. I think the opposite is often true. Support is what determines whether the real story can continue. A Navy can survive a temporary shortage of attention. It cannot survive a sustained breakdown in movement, repair, handling, fueling, or supply discipline. The combat arm may deliver the decisive public image. The support arm preserves the conditions under which decisive public images remain possible. That is also why logistics is so closely tied to confidence. Commander does not need merely a ship that exists. He needs a ship that can remain fueled, repaired, stocked, and materially supported in the ways his mission might require. A maintenance leader does not need merely a tasking list. She needs the people, tools, movement paths, and technical practices that allow the tasking list to become completed work. Confidence in naval power is therefore never confidence in the combat platform alone. It is confidence in a support environment that has proven it can keep the platform viable. If you want to know what a mature Navy looks like in peacetime footage, this is one answer. It looks like a force that keeps rehearsing the unglamorous connective tissue that prevents distance from winning. That phrase matters. Prevents distance from winning. Distance is always trying to win at sea. Distance eats time, stock levels, patience, maintenance margin, and assumptions. Every replenishment evolution, every crane drill, every fuel system assembly, every shipyard transport action is part of the Navy's larger refusal to let distance win cheaply. The hidden fleet is therefore not secondary to geography. It is the Navy's answer to geography. Oceans are large, bases are finite, demand is constant, ships wear down, deployments stretch, and systems age. Support is how a fleet argues back against those facts. Sometimes the argument takes the shape of an oiler beside a destroyer. Sometimes it takes the shape of a cargo ship returning from a long deployment. Sometimes it takes the shape of a field sterilization course, or a crane team at Cheatham Annex. Sometimes it takes the shape of welders in a shipyard shop. Different forms, same argument. There is a useful discipline in staying inside the DVID's boundary here because it ups us honest. We do not need inflated numbers or dramatic unsupported claims to tell this story well. The public record already gives us enough. Gives us recurring replenishment, recurring support terminology, recurring shipyard craft work, recurring expeditionary logistics training, and recurring language about readiness, mobilization, support, and sustainment. That is sufficient to tell the essential truth. The fleet keeps fighting only because a larger support ecosystem keeps solving ordinary problems before they grow into extraordinary ones. Ordinary problems are easy to dismiss when they are solved. Fuel transferred, cargo loaded, welding completed, crate moved, part calibrated, drill validated, medical gear sterilized, recovery supported. But an unsolved ordinary problem has a talent for becoming a strategic embarrassment later. Navies know this. That is why they invest attention in what outsiders are sometimes misread as routine. Routine is another word that deserves rescue. When people say routine, they often mean easy. At sea, and in military maintenance culture, routine more often means disciplined repetition of things too important to improvise. Routine is the form by which seriousness survives time. The hidden fleet is full of routines because routines are how high-consequence work avoids becoming theatrical chaos. This helps explain why public DVID's descriptions speak so often in the language of readiness, support, deployability, and mission. Those are not random institutional buzzwords. They are the conceptual glue of the support world. A support ship is not impressive because of how cinematic it looks. It is impressive because it extends readiness. A crane team matters because it extends support. A fuel system supply point matters because it extends deployability. A salvage and recovery unit matters because it extends mission continuity into harder conditions. Shipyard shop matters because it extends usable life and functional integrity. In other words, the hidden fleet deals in extension. Extension of endurance, range, extension mission time, extension of repair life, extension of options. That may be the cleanest definition of logistics in this whole episode. Logistics is the art of extending options by defeating preventable limits. On a carrier, the grand strategy of Seapower is translated into small repeated motions. The public image is speed, noise, and launch power. The lived reality is routine. A watch begins, another watch ends. A signal is passed by hand because a pointing finger and a colored jersey can cut through rotor wash and engine thunder better than a paragraph ever could. A checklist is opened again, not because the crew is forgotten, but because memory alone is not trusted with dangerous work. That human routine is easy to overlook from a distance. Yet it is one of the reasons a carrier becomes more than a hull and an air wing. The ship is a system held together by people repeating safe actions until those actions become dependable under stress. On the flight deck, in a machinery space inside a ready room, at a console in the ship's command spaces, the pattern is the same. Verify, repeat, report, confirm, do it again on the next cycle. In official imagery and public affairs footage, the deck often looks almost choreographed. A plane director faces an aircraft with feet planted wide against the moving deck, arms cutting clear shapes through salt air and jet exhaust. Nearby, other deck crew members move with their own visual language around equipment and tie down points. Behind them, the sea state is never truly still. The horizon rolls, spray moves across the edges of the deck, light changes from gray morning to hard noon glare to the amber wash of work lights at dusk. The carrier keeps moving, and the routine keeps moving with it. That matters because the ship's purpose, as the Navy describes it, is to support sea control, strikes, and power projection. Those are large strategic words. But to make them real, thousands of smaller acts have to happen in sequence without unnecessary confusion. Fuel has to arrive where it is needed. Aircraft have to be prepared, moved, checked, launched, recovered, and serviced again. Messages have to move from watch station to watch station. Tools have to be accounted for. Safety boundaries have to be respected even when the tempo rises. A deployment article about the Gerald R. Ford Carrier Strike Group describes a force of more than 6,000 sailors. That number helps explain the scale of the human machine. A carrier group is not just a ship at sea. It is a floating routine built from shifts, stations, maintenance periods, and handoffs. In a DVID-style deck sequence, a camera may linger on a yellow-shirted director guiding movement, then cut to a team securing gear against the deck, then shift below to sailors in a control space standing watch at illuminated consoles. None of it looks dramatic in isolation. Together, it is what allows a large formation to act coherently. The routine also exists because the environment punishes casual behavior. On the flight deck, there is heavy equipment in motion, exposed edges, hot exhaust, turning aircraft, and an ever-present need for precise spacing. In command spaces, the danger is different, but no less real. A hurried report, an assumption left unchallenged, or a misunderstood instruction can ripple outward into the larger system. Repetition becomes a form of protection. The crew repeats steps so the ship can operate at sea without every decision being reinvented in the moment. This is why naval professionalism often appears plain on camera. A sailor traces an item on a checklist with a fingertip. Another repeats back an instruction. The team pauses before moving a load. In footage from replenishment scenes, lines come across between ships while both vessels ride the sea together, and the motion of logistics becomes visible in its most physical form. Cargo, fuel, stores, parts, and mail all move through a narrow corridor of timing and trust. One ship maintains station, another receives. Crew members watch line tension, deck position, and equipment behavior while the sea lifts and settles beneath them. It is not glamorous work, but it is the reason the larger force can remain on station. The command room version of that same discipline is quieter. Screens glow in low light. Headsets, notes, voice circuits, plotted contacts, and repeated confirmations all turn raw information into shared awareness. The carrier does not operate alone, and modern naval operations depend on a wider sensing and reporting picture than any single bridge or shipboard radar can provide. Maritime patrol aircraft, long-endurance surveillance systems, and escort ships all feed the broader operational context. But no network removes the need for humans to process, prioritize, and pass along what matters. A flood of information does not simplify routine. It makes routine more important. That is the final argument of this episode. The floating factory matters because it reveals the real balance of naval power. Precision weapons matter. Flight operations matter, command decisions matter, but none of them last without the interior world that supports them. Beneath the deck is the factory floor of American maritime reach. It is louder, hotter, narrower, more repetitive, and more human than the famous photographs suggest. And once you understand that, the carrier stops looking like an icon and starts looking like what it really is. A hard-working machine built to keep thousands of people and dozens of aircraft ready, fed, repaired, and operational in a place that never stops moving. That machine also depends on something less visible than metal and procedure. It depends on being managed before fatigue starts managing the ship. Long watches, interrupted sleep, heat, noise, and repeated routine can wear down even experienced crews if the command climate stops respecting the human limit beneath the technical mission. The hidden city is therefore not only a masterpiece of engineering density, it is also a daily test of leadership. Good leaders keep the factory from confusing endurance with carelessness. They know that clean inspections, safe maintenance, accurate inventories, and honest watch relief all begin to degrade when people are treated as if they were interchangeable parts instead of the most failure-sensitive system on board. That is why the carrier inspires two opposite reactions at the same time. From the outside, it looks immense, powerful, and almost impersonal. From the inside, it is intimate, noisy, repetitive, and dependent on small habits being done correctly thousands of times. The floating factory is not impressive because it hides complexity. It is impressive because it keeps complexity functioning under pressure. And that is the real story below deck. Not mystery for its own sake, but disciplined human labor inside a steel city that has to remain livable and operational while the ocean keeps moving around it.